Okay, before we go through today's topics, I just want um, to answer the confusion with regards to the assignment submission. Yeah, I think there's a lot of confusion about the summary page. So before, in the old format of the class, where there's a lot of task for the assignments, then it's a page. But I will also accept a summary section. Maybe the top part of your assignment will be a summary, and it should be really simple. So I'll show you one of my submissions for the same for a class with the same format. It's taught by Dr. Alemi as well. So here's my summary. It's really simple. So I just wrote down question numbers for the task, and I just said approved by peer teacher because that's what he needs us to say. You will just say that task one, I got the same answer as the teach one, right? Or if you're having difficulty, tell me about the difficulty in the summary section so that I can reach out to you and help you. Okay. And then after the summary section, then you can put in as much detail as you want for your submission. So this is my sample submission for that assignment. And please, if I ask for a code, do not put in screenshots. Just paste them, just like what I did here. Yeah, it will be easier for me to help you if you're having trouble with the code. Okay. Sometimes reading code from a screenshot is difficult. Okay. So that's it. Any other questions? So I gave some of you 0, not because it's a pass or fail assignment. So just submit again, and you will get a passing, which is 100. And those that participated last week, who are Johnny, Lana, and Ikra, you'll get additional 5 um, for that assignment. So yeah, just submit. There's no penalty. Just resubmit. Okay. Now we can start. So this is the second session that we have for data preparation. Um, again, no right and wrong answer. How did any of you watch um, the teach ones, right? Of Lana and Shatrini. I hope you did. Okay, I'll make Shatrini and Lana as moderators because they will be going around the groups later with me. Okay. All right. So I suggest that you watch the teach one videos because that will be your assignment for next week. Okay, for next week, and I think they did a really good job. Yeah. Okay. So now let's continue with that. With that. With our data preparation. So this is data preparation part 2. Right? Okay. Just a recap. So last week we created the person characteristics dataset that merged demographics and survival together to a single data set called person. Okay. And then we started the processing for the antidepressant dataset. The antidepressant dataset and the data that they hold will be our main dataset. Um, moving forward. Okay, so we started with some simple data cleaning steps like grouping similar antidepressants together, removing unneeded columns and duplicate data, and then we proceeded with a very long uh, code in order for us to find the relevant antidepressant dates and dosage. Okay. So what do we do next? Right. So we will continue today with our data preparations. Then we will break out into lab sessions so that you will be doing your all of us coding, following the teach ones of Lana. The part one is Lana, and the part two is Chatrini. Okay, and then we will by 6:30. We will sorry by 9:30 we will end and rate the teach ones. And then once you rate the teach ones, you can go um, except for Wafa and Jenny. They will stay behind because we will be preparing for your teach ones next week. Okay, and as you saw, whatever I discussed this week will be the assignment that will be discussed with the teach ones next week. Okay, so the intention is I will confuse you guys, and the teach one people will help reduce that confusion. Okay. So what are our next steps? Now, last week, we ended with a data set that looks like this. Okay, um, a person, an antidepressant or AD grouping, and then the start date and end date and the dosage days for 3 trials, all in one row. Right. I told you that this is a good way to do it, at least for this particular purpose, because it's easy to visually see it. But when I pre-check the requirements for this particular research that we are conducting, we are going to add a lot more data, a lot more processing into the data set, and this format will not be um, the best format for us to do that. Okay, so we have to flatten the data. I call it convert. I call it flattening the data, but it's also doing it as converting it from a long format, from a wide format, which is it's wide, to a long format. Okay, so what I will we'll do that. We'll do that. Yeah, and then we will create data points to tag remissions using the antidepressant data. And then once we get those data points and that flattened data, we can create a main analysis data frame. Our objective is to just create one data frame. Remember, we have 4 data frames when we started. Now we have like 3 because we combined the demographics and the dead data frame together. Okay, now we have only 3. By this time, we will combine the person and the antidepressants data frame together. So we will now only have two data sets. So what we call our main analysis data frame, which is built on the antidepressant data that we will process combined with the person characteristics. So that's our main analysis data frame. And the other big data frame remaining, the disease data frame. Okay. So now that we have our main analysis data frame, we can calculate some other indicators that we are interested in, such as age. So the age when they started the antidepressant, and of course the age when they died. Um, I will teach you the concept of converting a variable that's continuous. So when we say continuous variables, it's a variable that that is a number, right? Usually it's just a number. So it's continuous because it doesn't really have an uh, really have like um, set limits, right? So you cannot just say 1, 2, 3, 4, 5 because there might be 1.5, there might be 1.51, there might be 2.6356, right? So it's continuous. There's no definite discrete uh, divisions with the variable, but we want discrete variables as much as possible when we are analyzing data, right? So we will convert age into buckets. So that means instead of having an age of 15, we'll say that you are between the ages of 13 and 29, right? So we will create age buckets, and then we will convert those age buckets into what we call dummy variables. So in statistics, a dummy variable um, is a column that has just 1 and 0, indicating the presence of that variable. Okay, so that means, for example, um, we created a dummy variable. We can create a dummy variable for race, for example, race. So there will be one column for race equals to white, another column for race equals to black, another column for race equals to, I don't know, Asian, and so on, right? And then that column will just have 1 or 0. So it will be 1 if that person has a race of black. That the column race equals black will have 1 if that person is black, and 0 if that person is not black. The column for white will be 1 if the person is white, and 0 if the person is not white, and the same goes for the Asian column. So we will learn how to do that. And finally, um, the last thing that we will do today, we will do a lot more, but today we'll end it this way, so that you won't be um, as confused, and try to you will also have a chance to learn the code better. So we will create indicators for antidepressant history. So what is the history of this person when it comes to antidepressants? And again, we will create indicators. It's just 1 and 0. Do you have this history, or do you don't, or do you not have this particular history? Okay. So we don't do a breakout yet. So I think what we will do is go to all of us and do what we have to do. It's not that. Okay. So now to flatten our data frame, our data frame last week that we left off is AD dates DF, or antidepressant dates data frame, right? Because we will flatten it, I'll just call it flat AD dates DF. Okay. So instead of person, AD grouping, earliest start date 1, earliest start date 2, earliest start date 3, earliest AD end 1, earliest AD end 2, etc. And dosage days 1, dosage days 2, dosage days 3. We will convert it into a table with just these columns: person ID, an AD grouping, and then a trial number, right? We will have either 1, 2, or 3 as a trial number. And then what is the earliest AD start for that trial? What's the earliest AD end for the trial? And what is the dosage days for that trial? Okay. So to do that, we will go through
all the possible trial numbers. So our possible trial number is 1, 2, and 3. So that's what this. So we will loop through 1, 2, and 3. And what we'll do is create a temporary data frame to store all the values for that particular trial number I, right? A trial number I. So if we have one, I will be trial number one will be I will be one. For trial number two, I will be two, and so on. Okay. So we will get the relevant column names and for that trial and store it into a temporary DF. Okay. We will rename the column names of the temporary data frame. Okay. And then we will store the value for the trial number, which is just equal to I. And then finally, append that using concat is appending the table into flat AD dates DF. Okay. And then we will sort based on person ID, AD grouping, and trial number. Okay. And this is what we get. So person ID, AD grouping, trial number, right? Earliest start date, earliest ADN, and dosage days. Now you will see there's these rows that do not have values for the dates. We don't need them because they're not helpful for us. So what we will do is now remove dates that are empty. Okay. And then just reset the index because when we drop a row, we have to reset the index. The index is this one. It's not a column. It's just called the index, and it allows us to process the data frame using index numbers. So if we didn't reset the index, there might be 0 and then 5 and then 15. The numbers won't make sense. Okay. So now we have a flattened data frame, and that will, because we will add a lot more columns to this data frame, and the initial one already has a lot of columns, and that will not look very good when we process it. So this one, it will be easier to use SQL concepts. Sorry, this table will be easier to do SQL concepts on. Left join will work really well. That inner join, of course, will also work really well. Search algorithms will also work really well in this format. Okay, so now we can start adding more data into this antidepressant table. So what else do we need to do? We also need to put in whether that particular trial in an antidepressant resulted in remission. Okay, remission is your depression was cured, right? Your depression, so the antidepressant trial was successful. Okay, so that's what remission is. If you so what are the rules to really tag whether the antidepressant trial resulted into remission? So first, we have to check the dosage days, right? If the trial is more than 70 days or 10 weeks, then we will create an indicator of those 70p or 70 plus, right? So that's P is for plus. So that means the dosage days is 10 weeks, more than 10 weeks. Then we also have to check if
the person did not start another antidepressant within that 70 days. So why? Because if within the 70 days the person started another antidepressant, that means that the current antidepressant trial is not working well. So I need to add another antidepressant. So if another antidepressant was added within this 10-week period, then uh, that's not good. So we will try to tag auth add, uh, or I think I renamed it already. Let me just other 80. Okay, this is really cryptic. So other 80. So other 80, meaning is there another antidepressant started, right? So we will give it a 1 if there was another antidepressant started within that period, within that trial, and 0 if there wasn't any antidepressant started within that trial. So the rule is the antidepressant should be used at least 70 days or more than 70 days, and there are no um, antidepressants started within that period. So if those 70p is 1 and other AD is 0, then remission is 1. Otherwise, it's 0. Okay. So that's what you need to code. Um, so NumPy, NP is NumPy, has a very good function for us, which will give us those 70p um, using with just one line, right? So if flat dates is greater than or equal to 70, then 1. And flat dates ADDF dosage days is greater than 70, then 1. Otherwise, 0. Okay, so that takes care of this. So when we find this, then we can check, right? Set 99 is greater than 70, so it's 1. 0, of course, is not greater than 70, so there's 0. 30 is not greater than 70, and there's 0. You can check other rows. But yeah, at least we can check that. We have checked that that works. Okay, now computing for the other AD usage will be trickier. Okay, so we have to create a function to do that, right? A function to do that and just apply that to our data frame. Okay. Okay. So the first thing that we wanted to say is if yeah. So the first thing we want to do is if there's only one row for that person, right? If there's only one row for that person, then that person is not taking any other antidepressant, right? So we return 0. So I call this a heuristic logic, like um, so that you don't have to do all of this. You can like have a logic that works every time. So it's a heuristic. If there's just one row for the person, then that person is not taking any other antidepressant. Okay? Otherwise, if there's more than one row for that person, then we'll store the trial start of that row of that particular trial, and the trial end will not be the trial end for that row. It will be trial start plus 70 days because we only wanted to know whether an antidepressant was started within 70 days, right? Okay. So now we get other rows, which is our flat data frame where person is the same person, but the antidepressant is a different antidepressant. So that's the other row, right?
what are the other antidepressants the person is taking? Okay, tell me. Um, put it in other rows, and now we loop through that other row, other rows. We loop through other rows. Check the start date for that for each row. And if any of the start dates fall between the trial start and the trial end, then we return one. Meaning we found an antidepressant that was started within the period of the trial of this within 70 days of the trial start. And if that function if that for loop ended, that means we didn't find anything. Then we return 0. Okay. So now we just create um, a, a func sorry we just create another data frame that just contains the person counts so that we can count for each person what's how many rows they have. Okay. um, and and then call and then sorry put an other antidepressant value by using apply. It's a function that you can do for a data frame so that you can call a function for each row in that data frame. Okay, and the argument is person counts. And if you see above, right, person there's two arguments for the function, row and person count. So the data frame apply will automatically pass row, right? It will go through each row, and so that what it will automatically pass row, so that you only have to pass person counts to that function. Now, by doing so, we already have another AD um, column. We can check. Okay. How did I check? No, did I check it below? Yeah, I checked it below. We can do that later. Okay. So now our remaining task is to tag remission. So remission is again use numpy where is when dose is equal to 1 and other AD is equal to 0. So if that happens, then give it a 1. Otherwise, give it a 0. So we have a remission column. Okay. So this is a technique that I use to check whether the rules were followed correctly. This is a good way to check whether um, this is a good way to check whether you have a flaw in your algorithm or in your logic. Okay, so here I want to check everything where I want to check whether my um, other AD column has correct values, right? So um, because 70p is easy to check, right? You just look at the dosage days. It's easy to check, but other AD a bit more difficult, right? So if it's 0, right? So give me all the rows where other AD is equal to 0, okay? And I just randomly took in a person. I took this person because he has a lot of antidepressant, this one. So it's easier to check multiple rules at a time for this person. So I put in, for example, okay, I can check if the rule for other AD equals 0 with this person. So again, I filtered using that person. So I can check manually. So this one other AD is equal to 1. Why? Because this was started June 2020 and ended July 2020. So I will look at other rows that's also started between these dates. Okay. So that means Toxipan, and I see
this one, July 13. Sorry, that's 2020. 2020, 12, 18, 2020, July 1. Okay. This is July, this is 12, 18. Yeah. So that there might be a problem here. Let's just yeah. I'll fix that later. Okay, and then you can check also. Oh, sorry. Other AD equals to 0 here. So okay, and then you can check for other AD equals to 1, and yeah, and again randomly select a person and do the analysis. Yeah, for remission, it might be easier to check, right? Because you will just see it should always be 1 and 0. So it will only be 1 when it's 1 and 0. So when I look at this, remission equals 1, I should only see 1 and 0, right? Okay. So that's how you create these tags, right? I'll check other AD. Maybe there's there's sort of a problem here. Why? Because this doxypan has an other AD tagged as 1, right? Doxypan for this as other AD is tagged as 1. And it started from June 27th to July 2nd of 2020, right? And we see that there's no start date that happens during that time, right? This happened July 30th, right? This really after July 2nd. Oh, now I know because we are looking at 70 days after June. Oh, so it works. Sorry for that. So after June 27th, we count 70 days, right? This was only done for 6 days. That's why, even if it ended, we still tag this one as another antidepressant because it was started within 70 days of doxypan, right? So that's why it's those 70p is 0, which is correct. It's 60 days. And there's another antidepressant started within 70 days of June 27, 2020. So our logic holds. Okay. So now we have this kind of a data, right? We have that kind of a data. And this can be the basis of our main analysis data frame. So we can combine the old person data frame that we had and combine it with this one. Why? Because remember, in that old data frame, we only have birth dates, but we cannot calculate the age without a reference date. We want this earliest AD start to be a reference date for age. That is the age when the antidepressant was started, right? Okay. So to do that, you just do a left join based on person ID, which gives us this long, wider data frame. So remission, and then this is the person columns of the person data frame. We just added them there. So now we have in the same table, we have date of birth, ethnicity, gender, sex at birth, and date of death. We can use that to calculate age. Okay. Now, when I try this out, it did not allow me to do the calculation because the data types were incorrect. After the joining of the data frame, the data types were not correct. So I did this to make sure that trial number is a number, is an integer, and dates are dates, right? They're not strings. And once we have the right data types, we can easily calculate for age in years. Okay, and there's no direct way that I know. Maybe you can research, but for at least for me, there's no direct way to calculate years. So it is the days divided by 365.25. Okay, and that will be a good approximation of the age in years. Okay. Now we cannot do the same thing for date of death, for age at death, because not all persons have a date of death. So we will only calculate age of death, age at death, if that date is not null. Okay, and you will do the same formula. And now our data frame has an age. Okay. Now we create age groups. So I got these age groups from the reference research that we are looking at, but it actually started at 13 to 19. But because I looked at the data, right, what's the minimum age and the maximum age, our range is actually 7 to 88. Okay, so I added 0 to 13, right, 0 to 13 to cover this someone with an age of 7.7. Otherwise, the other date groupings are match the the reference research that we will use, right? Dr. Alemi's research. Okay. So this is just um, me exploring the data. What's the minimum age and the maximum age, so that I know whether I can whether there are people above the age of 89, because this is the only age group that I have from the research. Are there people 89, and are there people younger than 13? Okay, so so that I can create the right age groups. Okay, so first to do now to group the age groups, right? To group the age groups, we define the bins. Okay, bins. So bins will be 0, 13, 19, 40, 64, 79, and 89. So that's 0, 13. So 0 will be the lowest. And then we go to the highest, right? 13, 19, 40, 64, 79, and 18. Okay. And then we create labels for each of those age groups, right? 0 to 13, 14 to 19, and so on. Okay. And then we use PD cut, the pandas cut method to cut the age into bins, right? To cut age at AD, age at antidepressant into bins, using the bins and using the labels that we created. Okay. So, and store that into age range. Okay. And now we have an age range. We will create dummy variables for that age range and make sure that they're an int type. So dummy variables, again, we convert the values into columns. Okay, and you will see later how that happens, and we will process them. We will now attach them together with the analysis data frame. So this is what it does. So we created an age range column, so age 41 to 64, age 41 to 64, etc. And then there's one column for each age range. Okay, so age 41 to 64 is one here, and the other are 0 because the age range is 41 to 64. Okay. So that's how dummy variables work. It converts a column that are categorical, discrete variables, that are discrete, um, into columns indicating 1 or 0. Right? And you can also, when you do some other practice of Python or data analysis, sometimes you will hear one hot encoding. So it's the same thing. It's creating dummy variables. So one hot encoding. Okay, there's optional tasks that we can do to drop the age range column because we don't need that anymore. We can also drop the age at AD column because we don't need that anymore. But we will not do that here because we will do that later on when we will just drop all the columns that we don't need, right? You will even drop this person ID column, right, at the end of the day. All right. Uh-huh. And our final task, I think this is our final task. Antidepressant history. And our final task will be um, to create indicators for antidepressant history. Okay. So what are the antidepressant histories that we are interested in? So one is same antidepressant no remission, or SN. That means I am taking the same antidepressant. I have a history of taking the same antidepressant and did not achieve remission. Okay. Same antidepressant SR, meaning I have the history of taking the same antidepressant and I achieve remission. And then different antidepressant no remission, or DN. So I have a history of taking another antidepressant and did not get a remission. Or I have a history of taking another antidepressant and achieve remission. Okay. So these are the indicators that we will create. Just 1 and 0, right? So SN will have a value of 1 if you have a history of the same antidepressant and no remission. It's 0 if there's no history. And similarly for the others. So they are also what we call binary variables, um, dichotomous variables, meaning the two values, right? Okay, so the first thing we do is create those columns and set them to 0, right? Set them to 0. Our logic will set them to 1 if it's applicable. Okay. Now we'll create a function to get the antidepressant history. I will just get a history type. History type, the values will be SN, SR, DN, and DR. Okay. So what history type do we want to get? And then this function will return 1 if that history type exists, and it will return 0 if that history type does not exist. Okay. So first is another heuristic logic. If this is the first trial, and you are looking for SN or SR, then there's no history. This is the first trial for that particular antidepressant, so you have no history of the same antidepressant. So just return 0, right? Otherwise, we do different rules for either SN or SR or DN and DR. Okay. So if it's SN or SR, okay, we are interested in previous trials where the person is the same person, but the trial number is lower, right? The trial number is lower, meaning it's 2. If your trial number is 2, then the trial number that you're looking for is 1. If your trial number is 3, the trial number you're looking for is 2 and 1. Okay, so where the trial number is less than the current trial number, it's an earlier trial number. Okay, and you are taking the same antidepressant because it's S, right? So that's previous trial. So it will differ. SN and SR just differs on what type of history we are looking for. Okay, if SN, you are looking for a history of no remission, so looking for a previous trial where remission is equal to 0, right? For SR, you're looking for a previous trial where remission is equal to 1. Okay, so that's the history will differ based on SR or SN. Okay, so if history is empty, meaning we didn't find that history. So if you're looking for SN, you didn't find remission equals 0. If you're looking for SR, you didn't find remission equals 1. If it's empty, then no history found, then we return 0. Otherwise, if we found something, then return 1. It exists. Okay? For DN and DR, we are doing something similar, but instead of the same previous trials, right? We are looking at other rows, right? Other antidepressants. Okay. So first, we will store the current start date of that antidepressant trial. And then we will get other rows as the same person, but different antidepressant, right? So those are other rows. And we only retain those other antidepressants whose who that ended before the current trial, meaning they're already passed, right? That ended before our current trial. Okay. So now we have other rows that contain the same person, different antidepressant, and ended before the current trial, the current trial. And then if you're DN, you will need to find a history of no remission. If DR, you're going to find a history of remission. Okay. Again, if history is empty, we return 0. If history is not empty, we found it, so we return 1. If I don't think any of the logic will not go through here, but we just put it here as a default, right? We return 0 as a default. Okay. And now we just call again apply to call that function for each row of our data frame, but we call it 4 times. Okay, once for SN, once for SR, once for DN, and once for DR. Okay, and we pass those as a history type, hist type. And now we have these columns: SN, SR, DN, DR. Okay, and we can check. Um, we can check if our logic is correct. So SN. Sorry. So these are all the SNs are equal to 0. Okay. Randomly select uh, a person from that data frame. I selected this guy again. And then just check. Okay. So SN was 0 for this because the trial is equal to 1. Yeah. So that's correct, right? So here, mirtazapine, SN is equal to 1 because the previous trial was only 39 days. So remission was 0. So it also fits our rule. And you can do the same thing for all of the other different combinations. So we have 4 variables, um, 2 values each. So you can check 8 times, right? I'm pretty confident that it works. Um, and that's it. Okay. We will add more indicators later. Okay. I'll stop here. This is where we will end. Any questions? Even if not related to this, I'll stop sharing. If none, I will. We have, if none, then our next step is a lab breakout. Okay. I will stop recording now.